Hi. Hi guys. Can you hear me? Quickly confirm in the chat section. Hi guys, very good evening. Confirm in the chat section whether you are able to hear me or not. Yes. Welcome to the session on TSSPDCL. Okay. In this session, I'll be discussing about previous year questions. Okay. From TSSPDCL, previous year questions from network analysis. Okay. Which is very fundamental, subject to start with. Okay, I think you must have already started your preparation for TSSPDCL Assistant Engineer. So here you're going to check, your preparation level. How is your preparation level with the help of previous year questions? Okay, so let's get started. So I'll take you to questions one by one. So let's see how nicely you'll be doing it. Okay. Boom. This is about TSSPDCL 2015 questions. Okay. Assistant engineer, not for sub-engineer, it's for assistant engineer previous year questions. Are you ready? Are you ready for the first question? Shall we go to the first question? Give it a thumbs up quickly. Let's see. You're going to learn some interesting questions here. We have some interesting questions. You're going to learn something interesting. Of course, they're very basic, very simple, but they're interesting as in they will tweak your brain a little bit. Okay? Yeah. Get ready for the first question. Oh, here we go. Okay. I'll give 3 minutes time. You try to answer this quickly, read it, and answer it. And see, you must be with your pen and paper. Okay, get ready with your pen and paper because you're actually solving the circuits, right? So you should be having pen and paper at least with you so that, you'll quickly able to solve it. Timer is already running here. Yeah. Just give the option. Which option is correct? Pratap Kumar. Okay. We got the answer from Pratap Kumar. Pratap Kumar is saying answer B. Okay. Okay. Anusha is also saying B. Fine. Yeah, quick. People have already given the answer. Others are still solving it. Let's see. Nothing wrong. I think you have to read the question properly. If you read the question properly, then I think you'll not do the mistake what you're doing. Read the question properly. Okay. There is some tweak in the question. Options here, they are like very much familiar. Series RL circuit means it's lagging. You're tempted to go for B. It's gone. You have to read the question, then tackle it or handle it. Yeah. The question is not asked about current versus voltage. It is something different, right? Read it. Okay, Raghava is saying D. Okay. A. All are not right. You're actually missing the right answer and you're giving all the wrong answers. So don't be in a hurry. You know the concepts. I know you know the concept. These kind of silly mistakes you should never do. Okay. These kind of silly mistakes you should never ever do. Okay. This is a silly mistake. That's why you're getting trapped. So sure. What is happening, guys? I told you, right? We got some interesting questions here now. Okay. It seems like interesting question is what? It seems like you know the answer, but there will be a little tweak. I mean, the best part? No one ever gave the right answer yet. Okay. Oh, finally we got some right answer. Okay. Finally, at the nick of time, Sarvat is saying Kareem. Subbu is saying C. Okay. Yogi is also saying C. Fine, fine, good. Okay, anyways. Let's see how to handle this question. What is given here? It is given a single phase RL series circuit. A single phase RL series circuit is given. And if current is lags the supply voltage by an angle phi, means it is saying clearly this is a voltage and the current, this is a current, and current is lagging the voltage by phi. It is given directly in the question itself. Okay, then what is asked here? If that is the case, then the voltage across the inductor dash the supply voltage by an angle of. Are you clear with the question what it says? It is talking about relation between voltage across the inductor. Voltage across the inductor. So once you have this RL and RL series circuit, just take it R and L. Okay. So there is some, some reactance will be there here. Some reactance will be there. So that reactance will give us, what is the voltage across inductor means what? Voltage across inductor will be I into XL, to be more precise. Ji into XL is VL. Okay, VL is equal to Ji into XL. Now at least try this. Now you got the tweak. Okay. Now I uncovered the tweak. Now others, you try. So VL is, he is talking about VL and voltage across the inductor and supply voltage. This is supply voltage. Voltage across the inductor will lead or lag. First tell me that. Okay. Voltage across the inductor dash the supply voltage by an angle of. Yes. VL is equal to Ji into XL. If you watch the phasor diagram concept clearly, I have already clearly explained with the help of animation. I explained the phasor diagram. Just YouTube it. Phasor diagram, PiSquare Academy. Then you will get it. From that, you have to now identify this vector VL. That phasor diagram will not just help you to solve this question, that will also help you to understand the complete idea about phasor diagram. Okay, animation wise, now we explained that. So where is VL? To get VL, take I, multiply with some XL. For now, let's take XL is equal to 1. For the sake of simplicity, I am taking. Okay, XL is some scalar, XL, I am taking it as 1. So basically, VL is equal to J into I. What is J? J is 90 degrees counterclockwise operator. 90 degrees counterclockwise operator means what you get? So this is I multiplied with J. You will be getting VL vector 90 degrees counterclockwise. This is JIXL. So this will be 90 minus 5. So voltage across inductor is leading. This is leading the supply voltage by 90 minus 5. So first of all, it is leading. The angle is 90 minus 5. I think now you got the idea. Pravalika Reddy is also saying it. Fine. So, shall we move to the next question? If you have anything unclear, you can ask me. See how tricky question is this? Simple at a tricky one. Yeah, there are many such tricky questions which you feel like, yeah, I know, I got the answer, but understanding the question has a key role. Okay, you have to understand the question properly. Are you ready for the next question? Give it a thumbs up so that I'll move to the next question. Yes, hurry up. Thumbs up. Yes. Did you like the video? Like the video first. Like the video first. Okay. Let's move to the next question. Again, I'm giving 3 minutes. Read the question or read the question and understand it, then answer it. Okay. If you can understand the question, the terminology of the question, then it is pretty much clear to answer. The problem is you may fail to understand the question. That is it. So be careful there. Read it carefully. Yeah. Yes. Yes, 2 minutes left for you. It's big. 2 minutes is good enough. Yep. Go ahead, quick. See, this is not a gate exam. Right? You need to be quick. In gate exam, you can comfortably answer the questions because you got a lot of time. But TSSPDCL or any state electricity board or any other exam, time is one of the constraints. So you should be handling the time properly. Otherwise, you're gone. Blocking this is okay. And just a name, right? You want me to give a hint? Okay, I'll give a hint. I'm pausing the timer for now. Let me give the hint. Then you take that hint and try to answer it. That's what? Understand the question. If you can understand the question properly, it's pretty much done. Okay? What does the question says? The question says 4 parallel connected resistors. 4 resistors connected in parallel. So we have 4 resistors. They are connected in parallel. First, quickly draw that what he said. He's talking about 4 resistors of value R, okay, and they're connected in parallel. Okay, so if 4 resistors are connected in parallel of value R, then what will be the equivalent resistance simply? Yeah, type. If 4 resistors are connected in parallel, what is the equivalent resistance? How much? Yes, come on. It's R by 4. It's R by 4. So this is done. Then what? Parallel, 4 parallel resistors are connected in parallel with, see here, 4, I think we'll have to divide it properly. 4 parallel connected resistors, 4 parallel resistors which is having equivalent resistance of R by 4, and they are connected in parallel with 5 series resistors. Means this 4 resistor combination is connected in parallel with 5 series resistors of value R again. So what is that equivalent resistance? It is 5R. Are you clear with what is given in the question? Yep. Clear? Okay. Now it is said, if it is connected across a supply of 210 volts, then supply current is 5 ampere. If 5 ampere is flowing, then what is the value of R? I think now we are able to solve it. I am running the timer from where we paused. It is running now. We already got some answers. Let's see. Raghava has answered it as D. Let's see what you are going to get it. I think it's visible, right? Am I blocking? Oh, let me go a little side. Yeah. You got 10 seconds left, others. What doing? Come on. Solve it. Thumbs up. Give it a thumbs up. Like the video. You're enjoying the session but not liking. You're crazy. Okay. Good. Anusha is saying. Srinivas is saying as D. It's pretty simple now. It's Ohm's law. It's Ohm's law, right? So what is the parallel combination of this resistance? 5R and R by 4. That parallel combination, you will get that R equivalent as, I have the answer, I am giving it, this will be 5 by 21 into R. That's what? R equivalent. Okay. Now, we know R is equal to, according to Ohm's law, V is equal to I into R. R is equal to V by I. R is equal to, which is 5 by 21. R is equal to, V is by R. You just solve this, solve for this R, okay, you will get R as D. It would have been a little simple if we got it as 21 by 5, okay, that is easy to answer it, but yeah, it is given like this, so you need to do some math. You will be getting this, answer D, okay. I hope you're clear. If there is something unclear, ask me, otherwise I'll move to the next question. Another interesting question again. All are interesting questions. It's not my created questions, it's previous questions. Okay. Yeah. Shall we go to the next question? Respond, respond, respond. I want you to respond. Come on. Huh? What the guy is doing, man? You're not responding. That's crazy. Respond in the chat. Chalo mat. Okay. Yeah, let's move. Thumbs up. Response is what? Give it a thumbs up. It's pretty good enough. Yeah. Bang. The timer has started already just now. Oh, this is direct formula based question. Even it is asked in one of GATE exam. Previous, you know, this year only. 2022 year. GATE exam, same question is asked in formula based, pretty much similar. Okay, concept is pretty much similar. Direct formula based. Direct formula based. You just put the numbers in the formula, you will get the answer. Just 1 minute question. Oh, we already got the answer. Pravalika Reddy has answered it already. Answer is given as A. Okay. Anusha is also saying it as A. Fine. Nice. That's a good response. A really good response. Wow. Amshi, Srinivas. Good attempt. What is the formula? Is it possible for you to write the formula quickly? If it is possible, I would love to see. If it is not possible, or if you're lazy, it's okay, leave it. Anyways, I'll be writing it. Others. It is simple. I think, let me stop the timer here. It's too much time. 1 minute is pretty much good enough for this. If you can't make it in 1 minute, I think it will take a lot of time for you. You have to know the formula. Mostly, unlike GATE exam, here in these SPDCL or any other state electricity board exams, you will get questions mostly based on direct formula based. Okay. So if it is a GATE exam, they'll ask indirect questions. You need to get some parameters by applying other formulas, all these things. But these exams, you have to be good with the formulas. Okay. How you'll be good with the formulas? Tell me. Yes, by practicing more. You need to keep attempting the questions, man. Come on, that is the only thing. You should keep practicing the questions. Okay. How do you practice the questions? We have a lot of questions, subject-wise, level-wise questions are there. You can download the app. There you got all the questions. And previous year questions, free tests also there. You can also appear that. Download the link, description link, in the description it is given. Download the app from the link. You'll get all the details. Come into this. See, you need to keep writing. If you're getting anything new, you should keep writing that on your notebook. Okay. So here it is said an inductor of Q factor 10 is connected in series with a capacitor having a Q factor of 100. Then what is the overall Q factor? So for that, formula is simply 1 by total Q is equal to 1 by Q coil plus this is coil, or else let's take it as capacitor, fine. QL, inductor Q factor and capacitor Q factor. So you know this value, it is given as 10, this is given as 100. So all you have to find is QT. Okay, QT is equal to 1000 by 110, means 100 by 11. That's what a QT. That is straightforward. Formula based question. Wow, good. We already got formulas also written by some of our guys. Let's see. Yeah, Anusha Mohan. That's the formula you had written. Absolutely right. Absolutely right. And Pravalika Reddy. Yes, you're also absolutely right. The formula what you given is absolutely right. Okay, let's move to the next question. Others, have you written the formula? Have you written the formula? You have to write the formula. Quickly write it. I'll move to the next question. Bang. We got 9 questions from the SPDCL paper 2015. Okay. We got few more questions from NPDCL, TSNPDCL, GenCo, Transco. All those things will be discussed also in the subsequent lectures. Okay. But you will get all the complete question paper. You will get it. Check the link. Download the app. It's all over. Okay. And keep practicing the questions. Yeah. Question number 4. Wow. This is a really good question. You have to, again, every question is based on how nicely you're understanding the question. That's what the key aspect. You have to understand the question properly. If you miss to understand it properly, it's gone. Understand. It could be from measurements also, like sometimes people will say this is question from measurements. It's okay. Okay. Be it a measurements or networks, it's 3-phase circuits, right? 2-wattmeter method. Yeah. If you understand the question properly, there is a key line in the question. If you understand that key line in the question, it's over. I mean, it will be easy to answer. That's what I mean. Yeah, let's see. What's the key line? If you can say key line, what's the key line which I'm talking about? If you can say that, that's also fine for me. Yeah, you can give an attempt. Just 70 seconds left. Oh. Okay. I'll give the key line. What's the key line I'm talking about? Let me pause the timer for you. For now, I'm just pausing it so that, I'll give some hint. I'll give some hints. Then things will be a little more easier for you. Okay, I'll make it easy for you. A 3-phase, 400 volts, balanced, star connected load. It's all fine. Okay. Just a build up to the question. Now, of course, the numbers are important. Star connector takes a current of 2.5 amperes, fine. And the power is measured by 2-wattmeter method, fine. So we know from the 2-wattmeter method, W1 is equal to, you'll get voltage, current, all these terms. Then you will get here, what is this? 30 plus 5. But W2 is proportional to cosine of cos of 30 minus 5. Okay, cos 30 plus 5 and cos 30 minus 5. And we know the total power, total three-phase power is equal to sum of W1 plus W2. That is also pretty much clear for us. Now this says, if the lower value of two positive readings, so these two readings are giving positive value, that is what given by question. It says these two are positive only, not negative. So out of these two positive values, the lower value is 707 watt. Lower value means what? You will get 30 minus 5, this corresponding will be lower or this corresponding will be lower, tell me. Which one will be lower? Cosine, higher the angle, lesser the value. So, W1 is given as 707. W1 is given as 707. Then what is the value of power factor? So now if I complete the formula, W1 is equal to what? Root 3 into 400 into current is 2.5. Okay. Root 3 into VL, this is 400. IL, which is 2.5, root 3 into 402.5 into cos 30 plus 5. This is the formula. Now, this W1 is given directly as 707, but not directly, of course, indirectly given as 707. Now, the only unknown is phi in this. That is it. So, now, continue calculating for the value of phi. Your task. That's your task. Do it. Wow. Saidip has answered it as D. Let's see whether he is right or not. $15. Check it out clearly, Saidip. Everything is written clearly. You just need to check. Okay, do it. It's given, right? Option B. Yes. Option B is the right answer. Simple calculation. Now you know the formula. Phi values are only unknown. Understood? If you have any questions, you can ask me. Yeah. Is 2-wattmeter method. See, if you can understand this, one wattmeter is cos 30 plus phi, another wattmeter is cos 30 minus phi. Try to remember this. If you can remember this, then things will be a lot more easier. Further questions, there can be further few more questions can be framed. So those also will be easier if you can keep this 30 plus phi and 30 minus phi in your mind. Okay. See how nicely they're framing the questions. Moving to the next question. It's basically, they can, if it is a gate, they'll give it as a MSQ, multiple select question, if it is online exam. Okay. Yeah. Now read the question. This is simple. From the options, it is pretty much clear. Only 2 are correct. Okay, 2 options. So which of the 2 are correct? That's you need to figure it out. I think I told you also in one of our lectures, if you want to answer this kind of a question where with sort of realistic circuit, realistic RLC circuit, resonance circuit, okay, for that, yeah, anyways, we'll talk about that. Series branch to parallel branch equivalent and parallel to series branch equivalent will help you a lot in answering these kind of questions. So I think you can do it as a task, okay. So things will be a lot more easier if you do. If I have one resistance and one reactance in series, what will be its corresponding parallel configuration circuit? We do that. We got some answers. Pravalika is saying as C. Let's see. Okay, let me pause the timer and give some hints for you. First tell me, what about the impedance in current? This is exactly 180 degrees, it's not that 1800, it's 180 degrees, okay. Two branch currents are exactly 180 degrees with each other, resonant frequencies, blah 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 this. Okay, let's see quickly what is given. Regarding the resonance of two branch parallel circuit having RL combination in one branch, RL series combination. It's not necessarily they should give it as series. One branch is RL means it is R and L series. Okay. The other branch is just a capacitor. Just a capacitor. Like this. Now, what else is given? Which of the following statements are true? That's it. It's a simple question. The circuit is given. This is R, this is L, this is C. Suppose if it is asked for, just imagine it this way. If it is asked for R, L, C parallel circuit. If it is asked as R, L, C parallel circuit, then what would you comment on impedance? What will happen to the impedance? Impedance of this RLC parallel circuit at resonance. Yeah. Impedance is, yep. Tell me what will happen to admittance. What will happen to the admittance? Admittance is, Y is equal to this G plus J, this B. Okay. So, this is what Y. At resonance, imaginary term is gone, so only will have a real term which is Z. So admittance is minimum. Admittance is minimum. If admittance is minimum, then what will happen to the impedance? Impedance is maximum. Impedance is maximum. Impedance is maximum. Now, for this case also, I will say impedance is maximum. On what basis I am commenting? I can represent this RL series branch as resistance and inductance in parallel. Resistance and inductance is parallel. And this series branch, I'm just representing this as a parallel branch like this. Okay. Now this capacitance is as it is. This capacitance is as it is. So it is like RLC parallel circuit equivalent to. Of course, the values will not be no more R and L. The values will be different. This value of R, if I'm not wrong, R will be some function of Q, okay, 1 minus Q or something. I didn't remember exactly that. Similarly, L also, okay. So it is some, let's take it as R prime and L prime. Now I can treat this circuit as this circuit like this. They are just electrically equivalent in terms of resonance. Now if it is at resonance, this is also at resonance, then this is simple parallel RLC, then complete admittance will be minimum. If admittance is minimum means impedance is maximum. Impedance is maximum means current is minimum. So option A is right. So option B is wrong. Two branch currents are exactly 180 degrees with each other. Strange. How come these? No, they cannot be 180 degrees with each other. Let's see if this is a circuit. If this is a circuit, you already got some answers. Yeah. If this is a circuit, we know current flowing in this is a voltage I'm taking. Let me just take it in a fresh place again. So voltage I'm taking it as a reference. So current will be leading the voltage by 90 degrees. I'm just drawing this current IC. Then this will be IC means second branch current. This will be I1, first branch current. So the currents are not 180 degrees. Okay. So two branch currents are exactly, no, this is also wrong. So if you just look at the formula for this resonant frequency, you should be getting D as resonant frequency. So option A and D means, statement A and D means option D is correct. Even I too didn't remember the formula. Of course, if you remember, this will be the formula. Okay. But you know, you're pretty much clear about B and C, they're wrong. So pair is given. So A, B is correct. That is it. You check the formula. You should be getting this as a formula. Okay. Sir, check the circuit can be represented in RLC series resonance circuit also. How do you represent this in RLC series circuit form? Raviteja is saying, such circuit can also be represented in RLC series resonant also. No, you cannot do that. Equivalency, I'm talking about equivalency. R and L, if they are in series, now I'm representing that R L series branch into parallel branch. And believe me, this conversion of this into parallel branch will help you a lot, you know, when you are getting some questions, interesting questions like this. Even this question also. Yeah. Tell me if you have any further questions. I'll let you clarify, otherwise I'll move to the next question. See guys, there seems to be, you know, we're attempting for SPDCL, but the questions are very tricky and very interesting questions. I love these questions. Very good questions. Okay. Concepts, you need to recall the concepts. Yeah. Moving to the next one. Moving to the next one. That's what you need to keep looking at, these kind of questions. Download the app, you'll get all those details. Free tests are there, free videos are there, keep watching. You know, there are a lot more previous questions I have solved. You'll get all those details in the app. Just watch them for free. And then if you like it, if you want to go for paid content, go for it, otherwise it's your choice. Yeah. This, I think, locus diagram question is based on locus diagram. For gate syllabus, instrumentation guys are having this locus diagram, but electrical and electronic guys are not having in terms of gate. But electrical guys, you are familiar with this locus diagram during the circle diagram. Okay, induction machine circle diagram, and you're doing it, then you will get this concept. If that is clear, you can pretty easily answer this particular question. Okay. And in our induction machine course, a lot of students ask some interesting questions like, you know, why we are explicitly drawing the circle diagram for induction machine? Why not for any other thing? Okay, why you are focusing more about circle diagram in induction machine? Those all details I discussed in the induction machine course with animations, of course. Animations, we continuously do the animations. You don't have to ask, so do we have the animations? Of course, we'll have the animations. Yeah. just got 1 minute left. Oh, 2 minutes left. Good. Saideep as well as Pravalika. You answered it. Okay. So let me pause the timer and give some hints for you. Okay, I'll give some hints, then you can proceed. It is said a single phase circuit with a supply voltage V consists of resistance R and reactance X in series. Okay, so you have circuit. See, whenever you have questions related to the circuits, quickly draw the circuit. That will make a lot of things easier for you. But if you don't just draw the circuits, then obviously you will keep guessing it. Okay. Now, the locus of current is circle with a radius of dash when R is varied. When the resistance is varied, then the current will form at some value of resistance. You will get some current at some other value of resistance. If you keep on changing the resistance, the current will definitely keep on changing. If you just plot that current tip, it will form a circle. And he's asking about what is the radius of the circle. Simple. Let's see. Suppose this is a voltage. I'm just taking voltage here. Voltage reference. Now what if the resistance is 0? The resistance is 0. Resistance 0 means short circuit. So current will be lagging this voltage by 90 degrees. This is a current. Current will be lagging this voltage by 90 degrees. Slowly what is happening? Resistance is suppose increasing. From 0, it has gone little up. From 0, maybe 0.1, maybe 1. Then current will decrease a little bit. And the angle will be no longer 90 degrees, it will be less than 90 degrees. So if you increase the resistance further, so this will be like this, 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 this will be like this. I mean, you got some problem with this. Check karo. Nahi chal raha. Guys, I'll be just black. Seems this pen is not working. Just give me a minute. team has fixed on time. Yeah. Okay, it's working. So what is it? Yeah, as current as resistance is changing, it is forming a circle with a radius of dash. Okay, let's see. Let's continue further. So it is like this. So when I add these tips from the resistance, this is when resistance R is equal to 0. So it is gone to this point. It has gone to this point. So this is a point where current is 0, means R is equal to infinity. When R is equal to infinity, this current has become 0 because open circuit, so current is 0. Okay. So higher the resistance, current will be morely in phase to the voltage and current magnitude is reduced. So this is a semicircle. This is a semicircle. So if we continue this changing in resistance to negative value also, then you will get it as circle like this. Now the question is about what is the radius, what is asked for? What is the radius of the circle? What is the radius of the circle? What is the diameter of the circle, tell me? The diameter of the circle is I maximum, simply I maximum. When I is maximum? When resistance is equal to 0. When resistance is equal to 0. When resistance is 0, then current is voltage by, you have here impedance Z. Okay. In the impedance Z, R value is 0, then simply you have X. Then simply you have X here. Okay. Because we're talking about, of course, impedance, but when resistance is 0, this is simply X. So this length is V by X. So can I mark answer as A? Can I mark answer as A, which is usually the case for circle diagram. In case of circle diagram, this diameter is V by X. Okay. But it is asked for a radius. So the answer is half of this, which is B. Okay. It is asked for radius. You need to be clear with what is asked for. Okay. So probably saying, sir, I think for resonance question answer is A. Okay. So what's the question number for resonance? A means B and C are correct. Is there any possibility that option B can be correct? Look at this. I mean, this statement C can be correct. Statement C, Pravalika is saying a point. So I think for resonance question, answer must be A. Means B and C statements are correct. This is 180 degrees. Okay. Two branch currents are 180 degrees to each other. We have just drawn the phasor diagram also. Here. So for IC and IL to be 180 degrees to each other, then the resistance what we have here, this resistance must be 0. This resistance must be 0. But you have RL combination, so resistance is not 0, then you can never get C. So option A and option B are completely wrong. You cannot say they are correct. Okay. And if you see, here this says impedance is maximum, here it says impedance is minimum. Okay. So I did mark AB correct. No, AB is not correct. A and D are correct. So D and A means option C is correct. See, statements wise, what are the statements correct? Statement A and statement D are correct, means option C is correct, not D. Okay. So AB cannot be correct. Why? This says A says impedance is maximum, B says impedance is minimum. So even this cannot be the logically correct answer. So option C is the only correct answer. When we got it from the analysis also, we got option as C only. Okay. Yes. Okay, Praveen. Welcome. You are welcoming back and I am also welcoming you. Let's move to the next question. I hope, Pravalika, I answered a question. Oh, okay. Then I didn't read the question. Okay, which of the statements are false? Great, great. Yeah, I missed it. Come on, you're right. See, we just missed it. So these two statements are correct, but he said which of the following are false, and these two are false. Option B and C, so answer is A. Oh, my dear, thank you, Pravalika Reddy. I just thought which of the following statements are true. These kind of silly mistakes, I think we should not do it. Okay. Yeah. Shall we move to the next question? Yes. Alright. Okay. I think we can solve this. Try solving this. Let's see. Previous question we answered it, right? Yeah, we answered it fine. Read the question. I think you'll be able to answer this easy. Let's see how easily you'll answer it. Wow, we got all the answers. Saideep is saying D. Praveen is saying C. Saideep is D. Let's see what others got to do with it. Shall I give some hints? Let me give some hints. Others who are unable to solve it, just try to take these hints. So the first one who answered the question is Saideep. Yeah. An RMS voltage of 35 volt is applied across, it's not just cross, it's across a single phase RC circuit. Okay. If the RMS voltage across the capacitor is 28 volts, then the angle between current, oh, this is pretty much easy, I think. RMS values are given for RC circuit. Okay. So voltages are different means definitely they are in series. Okay, this is a circuit. So this total voltage is 35 and this voltage is VR and this voltage is EC, which is equal to 28 volts. Okay, so this is the voltage. Let me just draw the phasor diagram for this quickly. Phasor diagram would be, let's take current as reference. This is a current I, and correspond to this current VR is just in phase. This is what VR. Okay, VR and I are in phase. And what about VC? VC is equal to minus J IXC. So this is I, minus j means 90 degrees clockwise. So this is Vc. The resultant is V. According to KVL, total voltage is equal to sum of VR plus Vc. This is what the resultant. So it is asking about then the angle between the current and supply voltage, means the question is about this angle, power factor angle. Okay, are clear? Now I think you will be able to solve this now, because you know the value of V, which is 35, the length of this, and Vc is also known, which is 28. So all you need to find is 5. Let me continue the timer. We do it now. Explain everything. Just in front of you. Everything is in front of you. Do it now. Timer is running. You can't stop it. 15 seconds more. Give it a thumbs up. Like it. Like it. Hit that like button. Smash that like button. What are you doing? Come on. You're just enjoying it. It's good. So this length is 35. This length is 28. This is 28. So which one I should go for? So sine 5 means sine inverse of 28 by 35. If this gives the answer, if any one of these is answer, then you can mark it 28 by 35. I don't know what is matching. Okay, am I right? Are we doing right? If this is not matching, then you have to find out. I think cot is going to match it. Cot is going to match it means you have to find out VR. Anyways, you know now this is simple trigonometric issue. It's no more related to networks or anything, because once I have this figure, that is simple basic mathematics. Even a 10th standard kid also will be able to do it. Okay, just do that. Answer according to my answer here, it should be D. It may be wrong also. You try doing. Okay. Yeah. Let's go to the next question. Last but one question. Let's see what you got for this. Yeah, try. Now I think you got actual network questions. So far, some deeper network questions you got. Of course, they are lovely questions. Okay. They're really interesting questions. Yeah. There's a voltage across a current source A and B in the figure. I think now you land at actual networks. Maybe module 1 of networks. Actual network is so far on networks on. But this is basically the module 1 of networks. Okay. Which even a sub-engineer also, in sub-engineer exam also you may get it. Not necessarily in assistant engineer. Oh, you're taking 3 minutes also for this. It's not tolerable. Yeah, we got our answer. C. Some people are saying as C, some people are saying as A. But Anusha is saying it as C. First person to answer. Followed by some other comments. 54 by 5. Option C is ID. Weird. I think 3 minutes is too much for this, isn't it? If others are able to do it, means What? If you can't solve these kind of simple questions, nothing can be said, buddy. Okay. Okay. I think 3 minutes is much high for this. Okay. So I'm just stopping the timer in between. What is the voltage across the current source VB? I discussed some diamond rules. I gave some diamond rules in the networks course. Okay, it's not that. I know you must be having idea of formulas, but you forget when you have a right time, you'll forget the formulas. That is why I have given some interesting tips so that you will never ever forget those formulas when it comes to application. Knowing the formula is not the actual thing. Applying a formula is actual thing, right? So you get to apply the formula, then it comes, it has some fruitfulness. So you just take the course or maybe some free videos, keep watching them, then you will get some insights of remembering the formula. Especially when it comes to power electronics. In power electronics, people will cry for, sir, I am unable to solve, I am unable to remember the formulas. There are not many formulas, not many waveforms. So what the heck, I'll remember all those formulas? There is an easy way to remember all those formulas. You just remember 2 to 3 formulas, that's enough. You'll be able to reproduce almost 65 formulas. Okay. There is a video also in PiSquare YouTube channel only. Keep watching it. Was it free content? Yeah, there are a lot more content available. That will help you to retain some knowledge. Okay. Anyways, coming to this with the help of diamond rule. So first of all, find out the current flowing in here. How much is this? This is 3 ampere because it's a current source. This current is 3 ampere. Now applying current division rule, current in this and current in this, you find out what's the current in this and find out what is the current in this. Okay. Or else, if you don't want to do that, you combine this as they are in parallel. Combine into one resistance. What is the equivalent resistance? 2 and 8. This is 4 times more. So highest value is 8. 4 times more. 4 plus 1 is 5. This is what the equivalent resistance, 8 by 5. Now this 3 ampere is going through this 2 ohms as well as this 8 by 5 ohms. So the voltage VAB is equal to 3 into 2 plus 3 into 8 by 5. Which is 6 plus, how much is this? 24 by 5. So you should be getting 30, 54 by 5. Answer is C. So today I missed the session, sir, because of college. Okay, nothing to worry, buddy. You can recap, you can rewind the video after this session and watch it. You can join on the next session on time. Last question from this TSSPDCL 2015. This is the last question. Let's see how many of you will get to the right answer within time. Yeah. Diamond rule 2. You are lovely, man. Ravi Teja. That's what. I think he's saying diamond rule 2 means you must be PiSquare user, PiSquare paid user. They got some beautiful diamonds in every course. Yes, as per the diamond rule 2, you got this. Saideep is saying A by C means both A and C are correct. How come A and C are correct? A or C or both A and C? What do you mean? A or C? Okay. It must be A or C. Now, which one is correct out of those, A or C? Okay, go ahead. Go ahead and find out. You are very quick to choose 2 options and eliminate 2 options. Now, out of those 2, you need to pick one. You already picked one. Lovely. That's lovely. That's lovely. Saideep is a rock star of the day. He hailed it. Good. Keep it up, Saideep. Okay, we got a few more answers. Okay. I think this is not even a 3 minutes question. let me change the timer to 2 minutes only. Okay. Pratap Kumar is saying it as D. Prabalika is saying it as B. Let's see. Choose the instantaneous power of pure capacitive single phase AC circuit. Okay. Pure capacitive single phase AC circuit with Vm, Im and frequency or the peak and all these voltages respectively of the sinusoidal supply. We know very well, nicely eliminated by Saideep. Option B and option D are eliminated first. Why, sir? What they have done, sir, means we know if I just write the voltage, V is equal to Vm sine omega t. Vm sine omega t means what? Vm sine 2 pi ft. Vm sine 2 pi ft. Okay. Now I means Im sine 2 pi ft. Im is Im sine 2 pi ft. Instantaneous power means multiply these two. We know the frequency of the instantaneous power of a pure capacitor or maybe pure inductor, that will be 2 times more. You will get 4 pi fd, either A or C, not 2 pi fd. Okay, time period will be less. See, if you just draw the waveforms of the voltage and current, you will get that. This is a voltage. For a capacitor, current will be leading. So this is what the current. If you just multiply, you will get the power. That power will be something like this of double the frequency. Okay, so that's why he picked either A or C. Now out of these two, you just multiply these two, you will get the answer as plus 0.5 Vm Im sine 4 pi ft. If it is if it is a pure inductance, then you will get it as minus 0.5 Vm Im sine 4 pi ft. Whatever it is a plus or minus, you take the average of this and average of this, you will get it as zero average power. We are talking about instantaneous power, but average power or active power will be zero. Okay. That's it. If you have any question, you can ask me based on what I discussed. Saideep is saying power received by the capacitor is treated as positive. We get one option. If you treat as negative, we get other option. Just multiply those, Saideep. Once you multiply those, what you are getting? You have two equations, two expressions, V and I. Simply multiply them. Okay. Yeah. Simple product. That's it. That's end of this lecture. I discussed 9 questions. All those 9 questions are very interesting and crucial questions. Simple, but they will tweak your mind. Didn't? Yes. So catch you in the next session with maybe NPDCL or Transco or Zenco. Whatever you want, we'll go for that. And what all you need to do? You keep practicing more questions. Okay. You have to have questions. Every day you keep solving more and more questions. That's how your speed will improve. That's how your formulas will be upfront. Okay. There are a lot more questions are there in the app. You just download the app, keep solving more and more questions. That's it for today. Unless you have questions, we shall end the session. Okay, I think that's pretty much it. Bye. See you in the next session. Do you have something? Wattmeter question, please check, sir. What happened to wattmeter question? Saideep? Is something wrong with the wattmeter question? Wattmeter. Question number, next time keep writing that question number so that it will be easy for me. See, maybe options, you now know the equation. This is the equation. Saidip, do you have anything to say about this equation? Do you have anything to say about this equation? If this equation is clear, then keep, it's mathematics. It's just a mathematics. Give the equation to the calculator. That will give the answer. Let me use that calculator, root 3, because Saidip has been consistently doing well. He is having this question, means I should verify it once. 30 plus 5 is 5 by 6. Oh no, we didn't get it as that. According to you, what's the answer here? According to Saidip, what is the answer? Once a substitute, I was not getting that. Oh, how come I get that? It's for 0, right? This is 5 by 6 means what? It is 30 degrees only. 30 degrees means 5 must be 0. If 5 is 0, both are equal. How come one is more, one is high? No, this is definitely not right. You're right, Saidi. So, option D you're getting? Okay, let me do that. YT by 12. No, not even option D. No. Okay, let me solve it. Let me solve it from the scratch. That will make some sense. Cos 30 plus 5, because it is given in terms of cos only. So let's take cos 30 plus 5 is equal to, excuse me. Definitely we'll get it as, they'll get more than 30, right? Because 30 plus 5 is there. We should be getting more than 5. So if I just try option A, do I have that? Yes, I have it. No, I think all these options are not matching. Oh, that's my fault. You know what's the fault here? Why root 3 will come there? Huh? Root 3 will not come there, right? This root 3, why root 3 is coming? Root 3 is not coming. It's simply 400 into 2.5, because wattmeter reading is voltage across the voltage coil, pressure coil, which is the 400 volts, current flowing through the current coil, which is 2.5 into cos of angle between voltage and current. So simply it is 400 into 2.5, that will be this. Simply this is voltage into current. Okay, that is making the difference here. So voltage is 400, current is 2.5. Then you substitute this, yes, you will get this one as D. You're right. You're right. Absolutely right. Okay. Okay. Let's. Saidi, you got something to say? Should be D, sir. Yes. W1 is 30 minus 5. No, not according to 30 minus 5. It is 30 plus only. Because higher the value, lesser it is said, lower value of 2 positive. So it is plus only. Good. Okay. That's it. That's end of the session. No, sir. What's that? Yeah, 707. Yes, you're right, dear Saidi. Yeah, option D. Okay. Bye-bye. Catch you in the next session.